All right, let's begin, shall we? So just by way of review here, let's just sort of quickly review where we left off yesterday. Your earbuds should be out and your phone should be turned off, and you're giving me 100% of your attention.
85 is my final offer.
Need 100. So you'll remember that yesterday we started this little booklet here, and we were talking about problems where there was a constant velocity, and we used v equals d over t. And we talked about ones where there was average velocity, and oddly enough, we had the same formula. And the difference is that in one situation, it's moving at a constant speed, right? It's always the same.
Yeah.
And the second one, the average velocity, it changed. In fact, there was some where it changed. These were all constant velocities. There was some when it changed, well, this is just a straightforward one. Some when it changed direction, like it went right, and then it went left, and then I think it went right again, something like that. But then the third one, remember this one, where it actually went like this, right? And you had to find the result. You had to use what you've learned already. Yes.
What's that?
It's like cross country with a compass.
And it should be an up.
You're right. Like it'll say like basically it's vector cross country running. It'll say run for 2 miles in this direction.
It says you walk for 1.2 kilometers.
Maybe they're not very good at it.
I don't like it walk for 1.2 kilometers.
Hey, they need to listen, man. I'm teaching here. Pay attention. Okay, so we left off and we were here. So we're still talking about average velocity, and I've given you plenty of time to get to this page. I'm hoping that you've taken advantage of that. If you're still sitting there with your binder closed, as Mitch is admirably demonstrated, well, you don't have that. Oh, how long are we going to go before you ask me for it?
For 30 seconds.
Is that right?
How many days of physics do you miss a week?
Were you here yesterday?
Okay, so the second way to determine average velocity when you have a position time graph is by determining the slope of the line joining 2 points. So let's have a look at this here. In the example graph, the slope of the line in interval A would yield the average velocity for that time interval. Now we've talked a little bit about this already, right? So the slope of this line is the average velocity for interval A. Okay? So how would we do that? A little refresher here on finding average velocity. So this is going to be 6. This is 5, so that's 2. So A is going to be 6 minus 0 all over 2 minus 0, or simply 3 meters per second. The average velocity is 3 meters per second. Now, did it maintain that 3 meters per second for the entire trip?
Yeah.
Yes, it did. How can you tell?
Because then it's stopped.
It didn't change slope, right. The fact that it stopped, Lucas, doesn't really have anything to do with how fast, whether it was constant here or not.
You said for the whole trip.
I meant for the whole interval A,
Well,
is what I mean. Fair enough. Okay, but because this line is straight, right, Gage? Because that line is straight, it maintained that. So determine the average velocity for the remaining time intervals as well as the entire trip. Let's go ahead and do that together. So what's the average velocity for B? How can you tell it's 0? Because it's flat. We don't even have to do that. 0. C.
6.
Look at those data points. This is at minus 10. It's not 0. Minus 10, subtract 6, all over 10 minus 6 is minus 16 over 4. The average velocity, or the slope, is minus 4 meters per second.
Why do you have 10
Because
Oh, right.
the time is 10 here. The second one is 10. 6, right? What's D? 0 again. How do we know? It's flat. What's E? The slope of this steep line here, it's going to be positive. I've got minus 4 and minus 6. So minus 4
Minus 10.
no. It's actually, it's going up. How much does it go up?
What is it? It starts.
Minus 4 subtract, minus 10. Is that what you're saying, Lucas?
Yeah.
I apologize. I didn't know what you meant. All over, the x's are at 11, 12. It's going to be 13 minus 12. It's just 1, right? So minus 4 subtract minus 10 is really plus 10. So that's actually 6 over 1 or 6. Exactly. In all of these cases, the line was straight and the velocity remained constant.
Why is 13 minus
Yeah, that one, that last one.
We'll get to the last one in a
Why is
second.
13 minus 12?
Because I'm at 11, 12, this is 12 seconds, and this one is 13. Now, as Lucas has seen here, this one is curved, which means the velocity is doing what?
Increasing.
Well, it's certainly changing. It's changing, right? Would we all agree that it's changing?
No.
Okay. Is it speeding up or is it slowing down?
Speeding up and coming to a constant rate.
It's slowing down.
Why do you say it's slowing down?
It's getting closer to flat.
Closer to getting flat. Exactly. It's flattening off. It's steep is because slope is becoming close to 0. It's slowing down because the slope is getting flatter. Remember, this slope is stopped, right? This is steep, this is flat. So it's slowing down.
That's when you're increasing. That's what's
If it was speeding up, what would it look like? It would go like this, right? If it was speeding up, it would look like that. Okay, so the average velocity, you actually join the endpoints like that. That's the average velocity, is the slope of that.
So you,
No, it's not cheating at
it
all.
is cheating.
How is it cheating?
Because why don't you find the curve? And just-
How do you find the slope of a curve?
You can. Well, and that's a silly question.
So we're going to find the endpoints and we're going to find that slope. I'm going to do it in this spot right here so that I can see what's going on here. So my slope for f is going to be y value of 0, y value of minus 4. So 0 minus 4. X value here, this is 15, 16, 17, 18. This is a x value here of 13. So it's going to be 4 over 5 or 0.8 meters per second. 0.8 meters per second. So I want to show you something here. You're right. You don't solve it any differently. The only thing you do is just sort of, you pick the endpoints, right? Now, this slope right here, does the slope of the curve ever equal 0.8? Like, what about like right there? No. Is there a point somewhere here where it's going to be 0.8? Yeah, somewhere like right about, maybe right there, right? If I zoom in a bit, does there have to be some point where the slope of the curve is exactly the same as the slope of that line? Yes, there is some magical point right there where the, if I dare say, the instantaneous velocity, the slope at that particular instant, is equal to that magical 0.8. And before here it's greater than 0.8, right?
Right.
Steeper. And here the curve, the black one, is less than 0.8, is it not? Right? Nod for me. Especially if you get it. Good. Okay. So, some summary points here. When determining the average velocity, the following points should be kept in mind. Positive slope rises to the right, yields positive velocity. Negative slope yields negative velocity. Important to know. Positive velocity moves for movement in a positive direction, well, duh, and negative velocity from the negative direction. A straight line portion on a graph indicates constant velocity. This means that the average and constant velocities are the same value. If average velocity over more than one straight line portion of a graph is desired, then you must construct a straight line from a point in the graph at the beginning to the point at the end. I'm going to come back to that one. Horizontal line indicates zero slope and therefore zero velocity and it's stationary. Let's go back to this one here because I meant to do this. What is the overall average velocity for this one here? What's the overall? I got to get rid of all this stuff here. You say zero. Why zero? Yeah, if you connect the two, the start and the end, it's flat. The overall average overall is zero. So even though you go forward and stop, and you come backwards fast and you stop, you go forward really fast, you stop, you go forward and you slow down,
So you basically didn't go anywhere.
it's all for nothing.
Might as well stay at home.
Might as well.
Yeah, still you wake up in the morning.
When the football team runs around the track, one entire trip, Nate, what's your average velocity?
Nothing.
Zero.
Why 0?
Because you end up
Oh, we end up
exactly
the same
where you
place.
started, right?
So
Unless you
it's
stop
technically
before where you
pointless to
started.
do, right?
See if that works for you in practice.
There you go.
There's no sense in the fact because our average velocity is going to be zero. I know the answer to that. Take a second lap, Yuri.
I had to yesterday. I was
Isn't
the
that
biggest
what
smart
I
ass.
thought?
If you took a second lap, what would be your average velocity?
So,
Still zero.
It's pointless. We're going to the same
Unless you
place.
stop.
So running on a treadmill's average is 0.
Yeah, I guess your average velocity would be zero, right?
Starting and stopping.
It's the whole difference between velocity, vectors, and speed, right?
That's why I hate treadmills. You'll move, stand, like, in one place.
Okay. Let's talk about the third kind of velocity, and then I'm going to give you time to work here. Instantaneous velocity, V-inst. Now, I've already sort of briefly talked about this a bit here. If I asked you right now, if you had to define what instantaneous velocity means, what would you say? Like, what do you think it means?
like right now.
How fast are you going?
Right now.
No, right now.
Right now.
No, now.
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 Okay.
How fast are you going right now?
I'm on
0.
Right now, you're all going zero. Exactly. Okay. So, two possible conditions when V-inst is to be calculated. One, it could be a straight line graph, in which case you smile because it's going to be easy. Because the instantaneous velocity there is the same as there, is the same as there, is the same as there, and there, and there. You just find the slope. There's nothing to it.
That's a pretty straight line for being so fast.
Anytime you're asked for instantaneous velocity and the graph is a straight line, simply find the average velocity for the corresponding interval. Just find the slope, in other words. They're all the same. All the same. The difficulty arises when you get a curved line graph. Okay. How many people are intending to take calculus or advanced math?
Me!
Ah.
It sucks.
This is the basic theory behind calculus.
I hate calculus.
University professors will spend hours and hours and hours, and I'll give you the 30-second
I'm not
version.
going to university anymore.
On a curved line graph. In this case, the portion of the graph over which V-inst is to be calculated is reduced as shown in the diagram below. So, slope C, right, from there to there, well, that would be V bar, right? That would be the average velocity of that. See the curvy graph? There's the curvy graph, right? Slope of that is going to be the average. And as I said before, is there some point, is there some point on the graph where the slope of that line is? Yes, there is. Okay? So what we do is, as shown, as a shorter and shorter time interval is chosen, shown in the diagram as slopes C, B, and A, the line becomes progressively shorter, and the curve, Nate, becomes straighter between those 2 points. So between points, the C points, it's pretty curvy, right? Between points B, it's still pretty curvy, but not as much. Between the points A, from there to there, and then I'm going to even zoom in a bit,
She got screwed.
how curvy is that line?
Yeah.
Not very. And if I went even smaller and smaller and smaller, if I zoom in enough, I can basically take the curve and do what? Straighten it out, right? A little tiny one, not very short, or not very long, really short, but straight. And then you take that straight line and do you guys know what the word extrapolate means? It means like sort of like extend it Can you find the slope of that extended line? Absolutely, right? You're basically taking that little tiny line and you're simply stretching it out. That, my friends, is called a tangent line.
Straight line, tangent line.
The straight line is called the tangent line. The tangent line touches the curve at a single point. Have you heard that word before?
Yeah.
Quite often you hear about sometimes teachers, quite often me, I'll go off on a tangent. What does that mean? It means that I'm supposed to be talking about that stuff, but I end up going
that way.
off on a tangent.
Oh, so you're getting off topic.
I'm getting off topic. I'm getting off the path.
Like you are right now.
Yeah, exactly. But yet, also on topic.
Exactly.
Well done.
Oh,
Okay, so let's talk a little bit more about this, okay? Basically, blah, 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 tangent line, what I just said. All of this is what I just said. Okay? So, draw the tangent line that best approximate the slope of the curved line at that point. So what you do is you actually take out your ruler
I don't have one of those.
and you put it on the curve and you approximate the slope of the curve as best you can. You eyeball it. Now, is Mitchell going to get a different number than Lucas? Yes. Well, yeah, they might get the same because they copy each other. Will Josh and Dan get different numbers? They might. And that's okay, right? As long as I see what?
What do you want me to
The
draw?
line.
I want to see your line. I want to see you picking 2 points and you showing me how you get the slope. Again, like when we talked a little bit about sig figs, it's not the number that matters, it's the process. If you draw a line and show me 2 points and show your work, you'll be good.
You draw a line on that one?
Instantaneous, you just draw it.
To find the instantaneous velocity, it's simply, well, it's right here. V inst is the slope of the tangent line.
Cool.
Okay? V inst is the slope of the tangent line. Okay, so here's what I want you to do. On this goofy looking curve here, I want you to find the instantaneous velocities at A and B and C. And here's what I'll do, because everyone always says, is this right? I'm going to give you like about 2-3 minutes to do A, and then I'm going to give you an answer. Go.
Let's rise over run.
Rise over run. You need to draw a tangent line at A. So let me just get a straight line here. Okay, roughly. And you're going to take that line and you're going to put it at A. You're going to take your ruler so that it matches the curve at A. Right? So you snuggle up your ruler just like that.
Then what?
So the only place that should touch the graph is where?
A.
At A. It touches the curve at 1 point.
Then what?
Then what? Pick 2 data points. Pick 2 data points and find the slope. So there's 1 data point there, and I'm going to pick.
Sleep.
I'm going to pick that one there. If your line goes exactly through one of the grid lines are actually called lattice points. The grid lines are called lattice points. You can extend your line as far as you want until you find a lattice point. If you don't like them, you're going to have to pick like data points like that and then estimate. That's the only way.
Does it matter if I did 10?
No, it doesn't matter. As long as you pick the points and show me.
Okay, now what?
Now find the slope.
How do I do that?
How do you find the slope?
Y2 minus Y1.
Exactly.
But I
I
forget.
honestly never learned how to do that.
Really?
Yeah.
Well, it's time you learn.
I didn't know.
Y2 minus Y1 all over X2 minus
Which
X1.
one goes where?
Yep. This is X1, Y1, and this one is X2, Y2.
Well, it doesn't have to be those.
Doesn't have to be those ones.
Well,
So my Y2 is 8. right? 8, and my y1 is 1.
Is
So
x1, y1 always going to be the smallest number?
it's always going to be the one on the left,
The most left point?
the most left point. So x2 minus x1 is going to be 10 minus 4.
Dude, I got that too.
I got 7 over 6, which I think
I got 6 over 6.
1.18, am I right? What did I say earlier? Do you remember what I said earlier? 1.16?
Hey!
What I said earlier was, you're going to get
1.2 by the way.
different data points
Here, wait.
than your neighbor, and that's okay, as long as, Gage, I see what points you're using and you show me the work.
Mr. Bennett, I think you're wrong.
What do you mean it's racist?
Mr. Bennett,
You're not.
I think you're wrong.
1.16.
You wrote the same one.
It's by
You
two
even
minus
got your
one.
last points, bud.
Yeah.
Yeah.
8 minus 1 all over 10 minus 4.
Yeah.
Did you write them out?
It's better I like this.
Coordinates?
Alrighty, can you do the same thing for B?
Yes, I can.
Now B is a little bit different. I'll wait for a second or so and see what you think.
I'm still learning stuff.
That's fine, I'm not judging you right now. Yeah, the problem in B is that the slope of the graph changes, right?
Are we reading a lot of this line and slope stuff?
Yeah, okay, so don't worry about the fact that it might actually,
Because I just learned how to do this.
Follow the whole thing.
okay, like, for example, right, we say it can only touch at one point. Well, but it's touching again down here. That's okay. We're only talking about, like, localized touching. Localized touching. Like, I don't care what happens way down here. Like, you can't take your tangent line and go like this and say, oh, well, it's only touching there and there. Well, clearly that line is not estimating the slope of the curve at point B.
And that's wrong.
Yes, I know. So you bring in your ruler, right, and you try to match the slope. You're trying to match the slope of the curve at point
You
B.
got
You're
1911
mad,
like
man.
me.
You're crazy.
Holy cow.
Just
That's what
stop.
I did, mate.
1911?
Yeah.
911.
And extend it as far down as you need to.
Can we go inside the line or
Yeah.
outside?
Doesn't matter.
Minus
I'm going to go put mine in blue
10
or red. Let's go red.
equals something, 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 something.
Good enough.
Pick data points.
If it's a little bit off, doesn't matter. Doesn't have to be dead on.
Okay, here's an answer for B. I'm going to go with that data point there, which is 20. Oh, I like that one right there. 20 minus 10 all over 14 minus also 10.
Oh, mine didn't hit 10.
So that's going to be 10 over 4, or did you get roughly 2.5 meters per second?
Yeah, I got 2.
Like if you get anywhere between 2 and 3, I'm just going to quickly look at it. Yeah, they did it. Done. Good.
What if I get a negative answer?
If you get negative, I can tell that it's wrong. How can I tell?
Crap.
Because it's obviously up and to the right. That's clearly positive.
Number C.
Number C.
I'm very good.
Number C got negative.
Let's look at C, where the slope is going down.
Is this one to the left?
Where the slope is going down, let's just go back to here. Remember,
Like my IQ, it's going
negative slope means negative velocity.
So negative velocity.
So it's going down.
Going
Still agreeing that
down.
question.
I got 30 and 12. 30,
Everybody's
12.
telling me
That's what they match up. That's what they get exact points just about that. Oh my son. What the heck? Come on.
Is that close?
I don't think it's close.
I guess 22 and 24.
It's way easier with a ruler, actually, than to do it on screen here. Okay, I gotta rotate a bit.
Is Greg, you go with the highest point, the higher point first, or no?
Left to right. Left to right.
That's 22 minus 30.
I got 7 over -4.
You guys are gonna drive me nuts. It doesn't matter what numbers you pick. What matters is you've drawn a tangent line, you've picked 2 points, and you've got a slope. And your number is in the same ballpark as mine.
It's supposed to be negative.
All that matters. I'm going to go with that data point there. Is there another one?
Okay, I'm calling this negative divided by
Oh yeah, I'm going to go with those ones right there. I can't check everyone's, man. Just
Not me, it's not everyone. You don't see everyone here.
I'm going with these data points. I'm going with that one there, which is 3. Going Y2 is to the right. 3 minus 18. All over, 28. Minus 18 is minus 15 over 10. So Nate, what have you got for an answer?
1.5.
1.5 or minus 1.5?
1.5.
Negative. Why is it negative? Because it's down.
0 minus 12.
Is minus 12.
0 minus 0, I'm sorry.
Okay. There are 1, 2, 3, 4 graphs to practice with. Are there answers there? Please tell me there's answers there, Tyler. Yay, there's answers on the back page. You can check your own work. By the time you're done, you should understand the difference between average velocity, constant velocity, instantaneous velocity. All being told from a VT graph. Go.